We are discussing about chapter number 3, which is motion in a straight line. XT graph, VT graph. These are the graphs for accelerated motion. So XT, that means X and T, X on Y axis and T on X axis. Similarly, when we talk about VT graph, that means velocity on Y axis and time on X axis. dx by dt is V. We know that V is dx by dt. And the second derivative of this position x with respect to time is acceleration, that is dv by dt. That is double differentiation d by dx or d by dt of dx by dt. So d by dx of d by dx of dx by dt is double differentiation d2x by dt square. So the second derivative of any function is directly related to the curvature of the graph of that function. In xt graph, the point showed us what? Where the graph is more curved, the value of acceleration is more, and point at with this acceleration where this graph is less curved, then this d2x by dt square acceleration is small. So the point where this xt graph is concave up, that means this one, concave up, or you can say curved upward, the acceleration is positive and the velocity is increasing. Where in xt graph, if the graph is concave down, that is it is curved downward, the acceleration would be negative and the velocity will be increasing. So this is your xt graph. So at a point where this xt graph has no curvature, or you can say it's a straight line, the acceleration is 0. So this figure shows all the three scenarios we have discussed, the possibilities. That is, this is the first one, means let us start with the 0 one. Means here we have slope as 0 in xt graph. This is our whole graph. Here we have 0 slope, that is velocity is 0, and because it is curved downwards, so we say that okay, is this acceleration 0, velocity less than 0? Let me remind you again. When we have concave up, that is it is a positive slope, v is greater than 0 and acceleration is greater than 0. When we have a positive slope, again in this case, the positive slope means velocity is greater than 0. Always positive slope means velocity is greater than 0 and the curveness is 0 because it is a straight line. If you are getting a straight line, that is it is a is equal to 0 because it is coming at 0. See, this is at 0. This also is at 0. When we come here, we have 0 slope. There is no slope, so it is also curved downwards. That is acceleration is less than 0. In this case, we have a graph something like this. This is a tangent, so we have a negative slope. V is less than 0, acceleration is again 0 because their curveness is here. See, it is just like this. There is no curveness, so acceleration is equal to 0. When we come here, it has a negative slope because it is like this. So it has a negative slope, that is velocity is less than 0. And since it is, see, it is curving upwards, we say that acceleration is greater than 0. So in an xt graph, it's quite easy to decide what is the sign of acceleration. But what is the value of acceleration? Xt graph can give you the sign, but what about the value? In this case, we need VT graph. VT graph for moving particle. So from the VT graph, we can get average acceleration and instantaneous acceleration. The slope, that is V2 minus V1 by T2 minus T1, that is difference in the velocity at 2 time, difference in the time interval, delta V by delta T. This gives the average acceleration at any time interval delta T. So the instantaneous acceleration at any point is equal to the slope of tangent in what? In VT graph. If a particle is moving, the VT graph is parallel. If this is parallel to the time axis, the slope is 0. Like this. Here, the slope is 0. That is velocity time. Velocity is not changing with time. So there is no acceleration. The particle is moving with 0 acceleration. What it means is the velocity of the particle is constant. In this case, we say the motion is uniform motion. In the next scenario, in VT graph, as I just going to discuss with you, any other type of graph instead of this parallel line, the motion is known as non-uniform motion. Let us see a figure where you will see the slope of graph is positive. So what is the acceleration? If the slope is positive, in this case slope is positive, that means the acceleration is of the particle is positive. So here we see that the slope is positive, acceleration positive. What is this? This is v2 minus v1, this is t2 minus t1. So this is the slope, tan theta, m. Here in this case, here the slope is negative, this is negative. So again it will be v2 minus v1 by t2 minus t1, that is the case, but still the m or tan theta is negative, that is acceleration is deceleration or it is retarding. So the graph, it can be a straight line like this. So slope of this line will be same for any time in 12. In this we say, okay, the object is having a uniform accelerated motion. That is, we have a constant accelerated motion. For this motion, the average acceleration and the instantaneous, means at some duration or at any single point, both the acceleration will be same. And this I was talking about, this is, I'll just come to this in a short while. Let us discuss about the next one, that is this one. The slope is negative. See, the slope is negative. Slope is nothing but this angle. It is negative. So we say that it is deaccelerating, and this is also a constant accelerated motion because it is a straight line. It is constant, but it is deaccelerating. In this case, if the velocity of the particle changes continuously with time, see, it is changing with time. So slope of the graph will be different for any different time interval you take. Here it is different, this time interval it is different. So the average acceleration will be also different at different time intervals. In this case, we call it as non-uniform accelerated motion. So the acceleration at any time is equal to the slope of tangent drawn at the curve at the point of time. So any tangent being drawn, this angle is the slope which is giving you acceleration. So the velocity time or VT graph of moving particle can be used to find the displacement and distance traveled by the particle during a given time. So how to find this distance? The area under the curve of VT graph will represent the displacement of a particle over a given time interval. So this is very important. The area under VT curve gives you distance and displacement. So this statement is true for any type of motion. The area of VT graph above x-axis will take as, like this is the motion. So we'll take this as positive, this as negative. The net displacement is actually the algebraic sum of this positive and negative value or area. So if you want to find the distance traveled, see, for displacement, positive, negative. But for distance, this will be positive, this will also be positive, this cannot be negative. So if you want to find the distance traveled by the particle, then the negative area of a graph should be considered positive. This has to be considered as positive. Let us take an example, you will understand it more. This is a VT graph of a particle which is moving in a straight line, and we have to find the distance traveled during the first 2 seconds, means from here to here, and the displacement, total distance during the time 0 to 4 seconds from here to here. We have to find the displacement and distance. Acceleration from t equal to 0.5 to t equal to 2. So how to find this? First of all, as I said, we have to find out the area. So for the first case, from 0 till 2, this is a triangle, proper triangle. So half into base into altitude. What is the base? Base is 2. Altitude is what? It is 10. See, from here to here it is 10. This is 10. So half into base into altitude, half into AE into OB, which is the area of triangle OAB. And this is our triangle OAB. And this is half into 10 into 2. 2 cancels out, it gives you 10 meter. In order to find the displacement during 0 to 4 second, we will find out first the area of this section, that is OAB triangle, and this one means area of BCD. But this we have to take as positive. this we have to take as negative in computation of displacement. So delta x will be area of triangle OAB plus area of triangle BCD. OAB is half into base into altitude, that is half into A into OB. In this case we have half into base again BD into CF. Now this A is what? Plus 10 here. OB is again 2. In this case half CF is what? This is minus 10 and this is your BD, which is 2. So rather than taking this as minus, let us take this as minus 10. And when we compute, it is 0. So displacement is sum of the area, but the area which is below has to be taken as negative. That is why it is 0. But in order to find out the distance, we will take this area as positive and this area also as positive. That is, we just computed this to be 10, this to be 10. So 10 plus 10 is 20. Now we have to find the acceleration. So t is equal to 0.5 second, that is, we are talking about this point. What is the acceleration? Acceleration is slope of this line OA, which is simply 10 minus 0 by 1 minus 0, like this, 10 meter per second square. We come at 2. What is the slope of AC at this point, which is minus 10 minus of plus 10, means this line I am talking about. So this minus this by 3 minus 1, okay, means this area. So you get this as the acceleration. So this is A1, this is A2. Kinematic equation for uniformly accelerated motion. We have a particle which is moving in uniform acceleration, that is A is the acceleration along a straight line, which is say the x direction. Now at t equal to 0, the velocity is v0. At t equal to say some t, the velocity becomes v. So we have a velocity v here. The velocity time graph is like this. So we have say two areas. We can just say that if we are drawing v0 to v, we have one area is this, second area is this. You can combine this area in terms of trapezium also. But the derivation of kinematic equation for uniformly accelerated motion from the graph is very important, because three equations are going to come from this, and we are going to use this equation not here, but if you are preparing for some competitive exams, then these equations are very important. In this case, because we are talking about uniformly accelerated motion, the acceleration is constant. So the average acceleration and the instantaneous acceleration over certain period of time will be same. So acceleration, this A is what? Slope in Vt, we have slope of line AB. So this is V and this is V0. So V minus V0, and this time is t minus 0. So V minus V0 by t, what is this acceleration? Just take A here and rearrange. You get V equal to V0 plus AT. This is very important equation, first equation. So displacement of a particle during this time is equal to what? Displacement, as we said, it is just the area of region OABCD, that is OABCD, this area of VT graph. So what will be the area? As I said, we can divide it into two parts. One is this triangle, the other is a rectangle. So area of rectangle OACD and area of triangle this ACB. So what is this? This is from here to here it is V0, and from here to here it is T. So V0 into 2 is the area of rectangle. How about this area of triangle? We have this as T, this as V minus V0, so half into base into altitude, so half into V minus V0 into T. Let us say this is X, this is the displacement, and let us rearrange it. We get this as the equation, because we know that V minus V0 is equal to A. In the previous equation we just saw, this is actually equal to T, AT. So let us rearrange, because we know V minus V0 equal to A, put it here, and just solving this we get X equal to V plus V0 by 2 into T. If we just rearrange, we get V plus V0 by 2, because we are taking this half as common, and this is the average. So V is, say, some average is always A plus B by 2. In this case A is V, B is V0. So this is average. So we can write it as a average. The average velocity is V plus V0 by 2. From equation first, we get T equal to V minus V0 by A. Now let us put this in this 11.5. So when we put it here, x equal to v plus v0 by 2, we already had in terms of in the place of t we can put this. So we get another equation, x equal to v square minus v0 square by 2a. Take 2a on this side, we get 2ax is equal to v square minus vv0. So these three equations are very important. These are the equation for uniformly accelerated motion. So these are the equation we obtained assuming t equal to 0. We said that it will start always from here, t equal to 0, but and also x equal to 0. There is no displacement at time t equal to 0. But this is not always the case. We have to get more general equation. So t equal to 0, say it starts from some x equal to x0, and it is not starting from 0, but certain value of x. So what we can do here is we have to replace all the equation with wherever x is there, we have to replace it with x minus x0 to make it more general. So these are the three equations when we put x equal to x minus x0. So in this equation, v0, v and a, they have to be considered according to which the motion of the particle is going on in positive or negative. So while you are putting this any value here, you have to see that you have to put the value with proper sign. A particle with initial velocity v0 moves with a constant acceleration in a straight line. You have to show that the distance traveled in nth second is v0 plus a by 2, 2n minus 1. So let us take an example. This is 9 second, this is 10 second. So in order to find the distance between these two, what we will do? The distance traveled at time 10 and distance traveled by time 9, we subtract this, that is, say d10 minus d9 you have to do. Say if this is n, so you have to do dn minus dn minus 1. Exactly, it is being done here. So distance traveled in nth second is distance traveled in n second, which is this case, minus distance traveled in n minus 1 second. So let us put in place of t, we put n. In the equation we know v0n plus half an square. In the same equation we will put n minus 1 in place of n. So v0 n minus 1 plus half a n minus 1 whole square. Let us rearrange it, something will get cancelled, and finally you get this as the equation. A train is moving with constant acceleration. When the ends of the train pass by signal, their speeds are u and v. Calculate the speed of the midpoint of the train travel while passing the signal. So the case is, the scenario is like this. This is a train and this is the signal. It is starting from here. Then at some point it will reach like this. So the midpoint is just you can say coinciding with the signal, and the next is the train end reaches the signal. So this is the direction of movement. So the question is, what is the speed of the midpoint, this midpoint of the train, while it is passing the signal? So let us assume that the length of the train is L. The speed of the front, this means this front end of the engine, while it is passing through the signal, is say u. We just consider the train as a rigid body, so speed of all the say points will remain the same. And the speed of the back and bogie, last point, while passing the signal, say this is u. This means that the speed changes from this u, sorry, this is v. So u to v at a distance L. So this is L, this is initial velocity, this is final velocity. And we know we have equation v square minus v0 square equal to 2x, or v square equal to u square plus 2s. Let us put the values here. Initial is this, final is this. So this is the equation. We are just putting these values. When it comes to midpoint here, so suppose the speed of the midpoint of this train is v dash. This means the speed changes from u, initial velocity was u, it changes to v dash, but the distance is now L by 2. Again we use the same equation, v dash square minus u square, this equation is equal to 2 into L by 2, and this gives you one more equation. Let us divide 1 by 2 and you get v square minus u square, v dash square minus u square, this al gets cancelled, you get this equation. and let us rearrange it. You get v dash is equal to u square plus v square by 2 under root. Two particles start their motion from point A and B with velocity this much, these two. So A, B, one has velocity 252, the other has velocity 144. The acceleration is given as minus 4 meter per second square. In this case, it is 8 meter per second square in the direction A to B. So we have to prove that they will meet each other twice. So we will get some quadratic equation, we'll get some roots. Those two values are going to say that it is going to meet twice. So from where and when they will meet, we'll find this out. First of all, the time will be found, and then the distance will also be found. We have to consider the distance between A and B is 36. Okay. So let us convert this, because this is in meter per second square, this is in meter. Let us convert 252 into meter per second. So just multiply 252 by 5 by 18, you get 70. Again, we convert this 144 into 5 by 18, you get 40. So these are just the speed in meter per second. Acceleration A1 for first one is minus 4, the second one is 8. Now we'll just use the formula Vx equal to V0 t plus half a t square. For the first particle, we know the speed we have found out just to be 70, half into acceleration t square. This is the first equation. Now again, for the same equation, with the help of same equation, we are going to use the second one. But in this case, the distance is 36. So if somebody has traveled x, then other will be, if you say this total distance is x, right? So total distance is x, then other will be x minus 36. It might have reached here, so it has to be x minus 36. X minus 36, again, this is the velocity and this is the acceleration. We get another equation. Let us solve these two, or you can say just subtract these two. You get an equation t square minus 5t plus 6, which is a quadratic equation. I hope that you are able to solve this equation. You get two roots, t equal to 2, t equal to 3, and because the the count of time is 2, these particles meet each other at these two times. When you substitute this t equal to 2 in any of the equation, or t equal to 3 is any in the equation, you get x equal to 132 for the first timing. For t equal to 3 you get 192. So both particles will meet each other at 2 seconds, after 2 seconds at distance 132, at 3 seconds at distance 192. When brakes are applied to a moving particle, the distance it travels before stopping is called braking distance. We have to obtain the formula for the braking distance. So let us say that the distance traveled by the vehicle before it stops after the application of brake is ds. Because the object is here, or the motion is here, we are trying to stop it. When we want to stop it, say it travels a distance of ds, and we know that initial velocity is say some v0, but the final velocity will be 0 because it is going to stop. So we'll use this equation, v square minus v0 square is equal to 2ax. This is final velocity which is going to be 0 because it is going to stop, v0 square, and because acceleration is deceleration, that is, it is acting in the opposite direction, we have to take a as minus a, and when we rearrange this, we get ds equal to v0 square by 2a. So the when we brake it, or when we apply brake, braking distance is directly proportional to the square. It is directly proportional to the square of the velocity of the vehicle and the braking capacity. If you double the initial velocity, it will increase the braking distance 4 times for the same acceleration. And braking distance is an important factor when we are deciding that what will be the speed limit in school zones and hospital zones. So this is one more installment of motion in a straight line. We'll be taking one more. Till then, thank you so much and take care of yourself.